Hello guys, before discussing the present content of the video, I would like to tell you that most of the basics, rules, codes, syntax are covered in the previous tutorial. So I would request you to go there and follow it up to come to the present content of the video. So it would be very much interesting and fun loving for you to code. So let's begin with the present content of the video. Today we're gonna look at into the methods to give the waveform inputs in simulation behavioral model. So you know very well that after writing a code in the xilinx platform, then to verify that code and logic, we generate one simulation behavioral model. So there we give some inputs and we obtain some waveforms that are the outputs, and we check whether we are getting a desired or correct output or not. So there are three ways by which you can give these input waveforms. So first is a force constant, second is a force clock, and the third is a test bench. So we will be covering all the three methods one by one. So for that, we'll be implementing one logic of full subtractor. So, so before you would be having very well basic knowledge of what is a full subtractor. So this is the internal diagram for the full subtractor, and this is the difference. How we will be getting the difference, that is the a minus b minus c. So the difference output is given by A XOR B XOR C, and the borrow will be given as A bar B plus BC plus A bar C. So same logic we're gonna implement in a xilinx platform. So we will be using a direct assignment, that is a structural level, to implement the design. You can use either way, either of the three methods you can use. So directly we will get this logic using some operators. So let's switch to the coding part. So under the same project, I am creating a new source file. So I am taking a Verilog module, naming it as full subtractor. Next, finish. So I need three inputs. So I will be naming it as A, B, C, one difference, and one borrow. So your inputs are A and B and C. Output are D, difference, and borrow. So the difference is, so we'll assign the variable d as A XOR B XOR C. So this is the symbol for XOR operation, and for borrow we will give invert of A into B plus B into C plus invert of A into C let's run it. I'm taking some brushes over here. Let's run it. C is not assigned, sorry. So synthesis seemed to be done completely successfully. We have RTL schematic. Now let's obtain a simulation behavioral model. We'll give some force constant values. 0, 1, 0, and run it. So for that D should be 0, 1, 0, D should be 1 and borrow should be 1. So D is 1 and borrow is 1. So hence it shows that the logic is implemented well. So this the force constant method was the first method which among the discussion for today's topic, that is a force constant. So This was this first method. Let's check for some more input combinations. So what happens in force constant, you need to give the inputs one by one, and it is very tedious process if the number of input combinations are very high. So going to the value and giving a force constant one by one, it's very time consuming. So let me give this value this time as a 0. Okay, this is 1. This one also 1, I will give 1. Okay, and run it. So output is supposed to be um, difference is 0 and borrow is 1. Yes. So for both the combination you can see 0 1 1, difference is 0, borrow is 1. Now we will look into the second method, that is a force clock method. So close this. We will relaunch the waveforms. So let's give some values. This time for force clock, you need to select a force clock. Leading edge is 1, then 0 I am taking. And let's take the period of 2 and OK. Second is force clock. Leading edge I am taking is 0, and then I am taking 1, and C 0 1 and 4. Okay, let's run it. So we have obtained the waveforms for full subtractor using a force clock. So it is very simple that for various number of combination of inputs we are getting the output. So this is suppose for 1011 101, this is for 100, this is for 101. So let's see one and check. Once for 101 both outputs are 0. For 101 both the outputs are 0, so it is correct. And also you can implement this logic using a gate level also. And now let's see and have a look for test bench. So even for more number of input combination, we tend to use a test bench method. It is very formal and easy method. So we will be adding a new source. Now mind this, that here you need to select a Verilog test fixture. So I am creating the test bench for Subtractor. So that's why I'm naming it as f sub tb. And for f Subtractor we are creating. So as these are all the files in the same project, so you will need to select one file for which you are creating a test bench. Now click on next and finish. So automatically one file will get open and half of the code will be written, like such as unit under test are as such that these are the inputs and these are the output. and our inputs are stored in a form of reg, and the outputs are taken as a wire. 100 nanoseconds of initial finish is taken. So first initialization inputs are taken as 000, and we can take a similar combinations. So I am giving a time of 2 nanoseconds. So now this time what I will take, 0 1 0, and 2 nanoseconds of time delay. So what happens here, if you want to take this particular amount of inputs only, so the waveforms will be generated for these number of input combinations only. So 0 0 0 0 1 0 0 1 1, let's take 1 1 0, then I would like to take one more for you. Okay, let's take it 1 1, and this I'm taking as 1, and there are more combinations. You can try it on, right? So let me save and run it. Okay, so in running is I will need to simulate the behavioral model for this test bench. So you can see it is shown over here. It is successfully completed. Okay, so the last one was for 100 nanosecond, that's why it is taking so much. We'll zoom it in and we'll check the initial combinations. Okay, they are here. So guys, you can see if my input combinations are 000, my borrow is 0, and my difference is also 0. If my input combinations are 010, my difference is 1 and borrow is 1. Can we go to the truth table and check once for the input combination of 010? So it is here, it is 1 1. Fine. So this is how we got the implementation of simulation behavioral model by using three methods. I hope you liked this video, you like the learning part, and please do like and share if you like this content. And most importantly, you should enjoy and you should have fun while doing this. See, it is very interesting topic, and very interesting codes are covered in the whole playlist. So you should enjoy while doing it, and you should try to implement different kind of exercise, so it will be more fun for you. Also, the knowledge elaborates when you share it. It expands even more when you share it. So if you find any difficulty, please do let me know in the comment section. Until then, stay safe guys, and stay tuned, and thank you so much.